Hello, I'm Dr. Harper. This video is in Management of Operations, a memo assignment, memo number 4, Inventory Policy DD Duraware. So let's bring up the memo. This memo number 4, you see there's no date because your numbers may be different, but the procedure is the same. The inventory manager of the warehouse for DD Duraware Tire, Inc. has typically ordered a quantity of 900 each time an order is needed for one of their popular tires to take advantage of the discount provided by the supplier and save the company money. The following discount schedule has just been received, reflecting recent changes in the discount percentages. The manager still maintains that an order quantity of 900 is best, since it will save the company the most money because of the quantity discount. We can see here with a 900, a 10% discount, the acquisition cost or the item cost is $27 instead of $30. Assume the tire is expected to have a constant demand of 1,800 tires over the next year, and the inventory carrying cost is determined as a percentage of the acquisition cost, as is usual for quantity discount problems. Although they do not know the unit ordering cost or unit carrying cost per dollar of inventory, they have reported a total annual ordering cost of $100 and a total annual carrying cost of $9,000 for last year, with a lot size of 900 and an acquisition cost of $27. Because if they ordered 900, they would pay $27. The unit cost will apply to next year since no significant change in operations has happened. The president of the company would like to know if the manager is correct in his reasoning or whether another quantity might be better and why. So that's what's being asked. Is the manager correct in his reasoning? Let me highlight that, and that's the first thing they want to know. That has to be addressed in the memo. The second thing is another order quantity might be better and why. So two things there. First, is there another quantity that is better? And why is it better? And notice there is no EOQ here. But cost certainly could be an issue, but we need to think about what quantity is better and why is it better. The president, Ms. Dawn Deertracker, not the manager, has contacted us to provide her this information to be presented at the next planning meeting. Since she has been newly appointed to make changes in the company and the manager has historically set the inventory policies, she has demonstrated trust in our ability to provide a quality analysis by retaining us as one of her first consulting projects in inventory. So this sets the scenario. She's new. The manager has been there, has historically set the policies. She wants to know, is he correct in his reasoning, and is there another quantity that's better? Why is it better? And so she's come to us to bring that information. Prepare an appropriate communication within the scenario and also to the clients involved that adequately addresses the request. And notice I'm just using communications general because your communication requirements may be different every semester. So let's solve this thing. First, let's bring up Excel and let's copy this information down. Oops. There we go. Come down here a ways. Let's see here. Come down here a little ways and copy it down here. There we go. And this is the quantity. This is the range. This is going to be the discount. And this is the item cost. Okay, let's increase this so we can see it. There we go. So we'll start with this. And so we have this information available to us. Let's center everything. There we go. And now let's bring in this information. Okay, first of all, we have a constant demand of 1800. So let's pull all this information in here and start filling things in. Okay, first of all, right here we have a demand of 1800. Okay, we see that. Although they do not know the unit ordering cost or unit carrying cost per dollar of inventory, they have reported a total annual ordering cost of $100. So we have a TOC, total ordering cost of $100. Okay, and if you recall, the ordering cost equals the frequency, which is D over Q times C sub O. So we'll use that relationship here in a minute to calculate C sub O. And then they reported total annual carrying cost of $9,000. So we have a total carrying cost of $9,000. And if you recall, that equals the Q over 2, the average inventory, but for quantity discounts, it's times I times C. Oops, times C. Okay, and we have I is what we're going to be calculating, the cost per dollar per time, and the C is given up here to be 27. Okay, and so let's, this is for a Q of 900, whoops, Q of 900, and a C of 27. Because if this is 900, this is 27. Okay, very good. Okay, now we have this information. Now let's calculate C sub O. And then the I. So let's do that. Okay, let's see here. Well, from up here, we can see the C sub O is part of this equation right here. And so solving for C sub O, C sub O will equal, that's going to be TOC divided by D divided by Q. So just solve for C sub O. Okay, let's left justify that so we can see it. Whoops. There we go. Okay, and then C sub C, the I here, I will equal, we'll solve for I here. That's TCC divided by, and let's have Q over 2 times C. Again, there's our equations. Okay, so let's do it. Let's calculate it. Enlarge this, make this a little bigger. Okay, and so let's solve C sub O. That equals TOC divided by, open parenthesis, D divided by Q. And that's going to be 50. Okay, now this is going to equal TCC, which is right here, divided by, open parenthesis, whoops. Let's do this again. I hit the wrong button there. Let's do it again. Equals a TCC divided by, open parenthesis. It's going to be Q over 2. That's Q divided by 2. Close parenthesis. Times the C, which is 27. And there we go. And we don't need all those significant figures. Let's have 5 is good enough. Okay, so now we have the information to start here. As a matter of fact, let's bring this down here. Here's D. That's equals to 1800. Then let's bring these others down too. C sub O. That's equal to 50. And then I. That's equal to this number here. Okay, because we can use these numbers, and those will be very helpful to us to calculate our problem. Okay, so the first thing we want to do is the initial Q. And that's just the EOQ equation. That's the square root of 2 times our demand. And I'm going to left justify this, all of these, so we can see what we're doing. The square root of 2 times our demand times our ordering cost divided by, open parenthesis, I times the cost. And there it is. And then we copy that down. And now we can center it. So there's the initial Q. And then we have our feasible Q. Oops, let's take the... Okay, well, so here's our range over here. Let's make this a little bigger so we can see it. That's pretty good. Should be able to see that. Okay, so 90 here is in the range, so then that becomes feasible. These two are not in the range, so this is going to be 450, and this is going to be 900. Okay, now we have our feasible Qs. Very good. Okay. So next, let's we're going to be calculating our costs. So the first thing let's do, let's come over here and calculate our frequency. That's just D over Q equals D divided by the feasible Q. Okay, let's just bring that down. Let's get our frequency. We got it. Okay, and then we're also going to need our average inventory. Average inventory. And that's really simply feasible Q over 2. Bring that down. So there we have it. So we're going to need that information. So next, let's see here. Let's come over here and let's do the total ordering cost. Total ordering cost, which equal to frequency times the unit ordering cost. Total carrying cost equals the average inventory times I times C. Let me come over here and get C. There's the C. Okay. And notice that EOQ, this is EOQ, they're equal. We can copy these down. It's not going to be equal down here because it's not EOQ. This is going to be the total acquisition cost. That's going to equal our demand times C. Our demand times C. And then copy that down. There we go. And finally, we have our total cost here, TC, which is equal to total ordering cost plus the total carrying cost plus the total acquisition cost. And there they all are. And then right here, the minimum. And right here, you know, we can see what the minimum is. It's this right here. And so I'll just bring this down here. Tell you what I'll do. Let me just do it this way. Equal the minimum. So there's the minimum right there. Okay. Now, that's fine and dandy, but when you look at this here, you say, let's look at this a little bit deeper, a little bit more precisely. Let's see here. There's a lot of numbers here. Let's see what's going on. So that's the minimum cost. And so here's our categories over here. 1, 2, 3. So let's take these and bring them down here and paste them again. Okay. So over here we're going to have our bring our feasible Q's, and then for that let's bring our our frequency. Equal our frequency. Let's equal our let's equal our average inventory. And then let's also equal our total ordering cost, carrying cost, acquisition, our cost. Let's bring this together. Let's look at this. Let's see what we have here. Okay, now we do see here, once we collect this, that this is going to be the minimum cost. So let's box that in. So that's one thing that the manager has 900. So the minimum cost is really that one, is the 90, not 900, 1/10 of that. But why? Well, the acquisition cost is lower, so that's true. But notice the carrying cost is significantly lower. It's the carrying cost that really saves all the money. As far as ordering cost, the ordering cost is low. So sure enough, the 900 that the manager was talking about is true for the acquisition cost and the ordering cost in the purchasing department, but not the warehouse. And also that warehouse has so much savings that the total savings is really less. So if it's only cost we're looking at, that's pretty much a good way to look at it. And the middle one here really isn't even considered when it's looking at cost, because it's the middle. It's in the middle on all four of those costs. But on the other hand, if you look at the this should be frequency. I want this to be frequency. Let's bring the frequency down. There they are. Let's look at the frequency here and the average inventory. Okay, well, if we go with, first of all, here is what the manager said. The frequency is 2, once every 6 months. Okay, but if we go with the minimum cost, then we're asking the purchasing department, the buyers, to increase their orders by a magnitude of 10. They do once every 6 months. Now they're doing it 20 times a year. That's almost every 2 weeks. A little bit more than every 2 weeks. That's a lot. Okay. Well, it's somewhere around every 3 weeks, every 3.5 weeks or so. So that's a lot. In other words, if you want to increase the amount of work, you can double it here. That's not bad every quarter. But this is 20 a year. So going from here to here is a significant increase in amount of work in that department. Now, as far as inventory is concerned, it is cheaper here, but also you're decreasing this all the way down to 45. In other words, that's 1/10 the amount of inventory you're carrying. So right now, they are used to carrying 450 on the average inventory. But if you cut that by an order of magnitude, all of a sudden, they might have to fire people. Okay, so but another possibility is the middle one here. Look at 450. Let's look at this right here. Let's box that in. Let's shade it, and let's look at that. Well, it's not the minimum cost. But what's the difference between this and the minimum cost? Well, we can see here it is $250 over a year. So in a total cost of over $56,000, we're looking at a difference of $250. And for that $250, we're asking their purchasing department to go once every quarter, 4 times a year to 20 times a year. we're asking their inventory to go from 225 down to 45. And so these are major disruptions. Going from the 900 to 450 is a minor disruption, but going from 2 to 450 down to 20, this is a major disruption. So you have a minor disruption for just two. Instead of this, you can increase because of $250. You don't have that much of a disruption. So if cost is paramount, then we'll go ahead and go with 90. But if operations are more important, if they're warehouse people, the amount of work that they don't want to fire, or the buyers, they may have to hire more people, so the disruption of operations may be significant, going from the 900 all the way down to 90. Maybe going to 450 is better. It's up to you. However you want to communicate this, you can communicate this any way you want. This is my analysis. This is some ideas you can take from this, and then you can analyze this and report it and communicate it however you want to do it. So we're a team. I'm in charge of the analysis. This is my analysis. You're in charge of the communication. It's up to you to communicate. So that's all I have for this memo. I hope this helps. Between now and the next time I see you, I want to urge everyone out there to be safe and take care.